Hello, this is Mr. Huber. In this lesson, we're going to learn about solving systems of equations that involve a quadratic equation. We've seen systems of equations before. You have a system of equations, it's more than one variable with the same multiple variables. So we saw two equations with two different variables. We're going to see that here as well, but instead of a linear system where we learned about different methods from elimination and substitution to even graphing, okay, we're going to solve systems that have quadratic equations through substitution. Now remember, substitution is when a quantity is replaced with something that it's equal to, or we substitute it with something it's equal to. When we use substitution for systems of equations, these are the steps we can follow. First, we want to solve one of the equations for either variable. Okay? We can solve for x equals or y equals, doesn't matter. As long as we know what one of the variables is equal to, then we can substitute that expression into the other equation. And then we'll have an equation that's left with just one variable. We can solve the resulting equation for the one variable that's left over. And finally, once we have that, we can substitute back into an original equation to find the value of the other variable. So you'll notice here some things that are important with substitution. We're going to be substituting. Okay? When we use substitution, we're replacing something with what it's equal to, and we can eventually work our way down to find out what x is equal to, and then use that to find y, or the other way around. Once we know one variable, we can find the other. So let's look at what that looks like. Before we even see with a quadratic equation, just reminding what it'll look like if we substitute it in just a linear system. All right? So in this case, we want to solve for one of these variables in one of the two equations. Now you could pick, let's say, the first equation. Add 2 to both sides, you can get y equals. Here we could subtract 2y and get x by itself. So we can get any of the variables by themselves. I'm going to take the first equation, and I'm going to add 2 to both sides. So I add 2 to both sides, and when I do that, now I'm going to have an equation over here that's going to be y equals 3x plus 2. My other equation hasn't changed, and now I can substitute. I can take 3x plus 2, and I can substitute it into the other equation for y, because I know that's what y is equal to. So now I can take that second equation, and it's going to be x plus 2 times 3x plus 2 equals 11. I replace the y here with what it's equal to, 3x plus 2. And now I can solve this equation, x plus 6x plus 4 equals 11. I subtract 4 on both sides, and I'm going to combine my like terms here, x and 6x, to 7x equals 7. And then I can divide on both sides by 7 and get x equals 1. Now that I know that x is equal to 1, I can go back and plug that into either of these equations I'd like to. So I can take it and plug it into either one of these. I'm just going to take the first one, do y minus 2 equals 3 times 1. So I'm going to have y minus 2 equals 3 times 1. I replace the x with a 1. So I add 2 to both sides here, and 3 plus 2, because 3 times 1 is 3, is y equals 5. So my solution will be 1, 5. It's an x, y ordered pair that's a solution for that system of equations. All right, in this system of equations, we see the second equation is in a quadratic form. It's y equals 2x squared minus 3x minus 2. That x squared is a quadratic equation, and we've got them both solved for y. So what I can do is I can replace the y with what it's equal to. Y is equal to x plus 4. I can replace this y with x plus 4 equals 2x squared minus 3x minus 2. Now we have a quadratic equation. We could use any methods we want to solve this. We're going to see that factoring is typically going to be a good method, but if you want to use other methods as well, you can. You could complete the square or a quadratic formula. Okay, so anything that works to solve for x now, I'm going to subtract x and 4 on both sides, subtract x and 4 on both sides, right? And I'm going to get 0 equals 2x squared minus 4x minus 6. Now from here, if I'm going to use factoring, I can divide everything by 2, which is useful because 0 then equals x squared minus 2x minus 3. And now I can factor that, okay, to x minus 3 and x plus 1. The numbers that multiply to give me negative 3 and add up to negative 2, which then, I can go up here, I can set those each equal to 0. X minus 3 equals 0, x plus 1 equals 0, and then when I solve each of these, I'm going to get x equals 3, subtracting 1 to cancel that out here, and I get x equals negative 1. Now I need to plug those back into an original equation. I would suggest using the first equation. That's going to be easier than plugging it in here, I would think. You're just doing whatever x is plus 4 instead of squaring it times 2 and going through all those steps. So I'm going to use the first equation to plug these back into. So I'm going to have y equals 3 plus 4. And then over here, y equals negative 1 plus 4. So you get y equals 7, y equals 3. So my solutions are 3 comma 7 and negative 1 comma 3. So these are my two solutions, right? I had, when x was 3, y is 7, 3 comma 7. When x is negative 1, y is 3. If I graphed these two equations, okay, we have a line and a parabola. So I'm not going to draw out a detailed graph, but we'd have a parabola something like this. We have the line going something like that, right? And these 2 points would be the points where they intersect. Remember, when you graph a system, you're looking for the points where they intersect. So the points where they intersect, right, those would be the solutions. Right? Those are the two xy ordered pairs that will solve both of the equations. In this case, a line and a parabola. So just something to keep in mind, how those solutions relate to the graphs. And before we solve a couple more systems, a little penalty flag pause, and we've got a little bit of writing on there. We'll get out of the way here. But the only American state flag that's not a rectangle. The only American state flag that's not a rectangle. That's what it looks like. Okay? So I'm not sure if you can identify what state that might be. You might not know all your state flags, which I wouldn't necessarily expect you to. Okay, so that right there, I can't really even tell you. It's not because I don't want to. It's because it's a 4-letter word, and I want to be polite here on this video. I don't want to say any bad 4-letter words. It starts with an O, and I'll let you try to figure out the rest. So there's one state flag. I mean, it's the worst state going, so you could probably figure out what it is from there. All right, let's solve some more equations. Get that off. All right, so let's solve this system of equations. Okay, we're going to solve by substitution. So in order to do that, we want to substitute something in for a variable that it's equal to. So we could do a couple of things here. In this first equation, okay, we could take this and add 11 and find out what y is equal to, but don't even really need to. The second equation solved y equals x plus 1. So I can take this x plus 1 and I can plug it in there for y. So I'm going to have x plus 1 minus 11, because that doesn't change, equals x squared minus 6x. And now I want to simplify this. X minus 10 equals x squared minus 6x. And now to solve this, I want to get it set equal to 0. So I'm going to subtract x and add 10. I'm going to subtract x and add 10. Those cancel. I'm going to get 0 equals x squared minus 7x plus 10. And so now I can factor this. I'd have 0 equals, in my factors, numbers that multiply to give me 10 and add up to negative 7 are going to be negative 5 and negative 2, which I can take both of equal to 0. X minus 5 equals 0. X minus 2 equals 0. Okay, and now I'm going to solve both of these. X equals 5 and x equals 2. So x equals 5 and x equals 2, which I now have to plug back in to find my y values. I'm going to take my second equation in this instance because that's relatively easy to work with. Y equals 5 plus 1. Y equals 2 plus 1. So I'm going to have an x value of 5 and a y value of 6. I'm going to have an x value of 2 and a y value of 3. Those would be my two equations. Those would be the two xy ordered pairs that solve both of the equations. If I want to see if it works, I can take 5 and 6, plug it into this equation, take the 5 and 6, and plug the 5 in for the x, the 6 for the y, make sure it solves both equations. You do the same thing with the 2 and the 3. Let's try the 2 and the 3. Okay, so if I'm going to check 2 comma 3 in that first equation, I'm going to have 3 minus 11 equals 2 squared minus 6 times 2. Right? Every x is replaced with a 2. Every y is substituted to replace with a 3. So I'm going to have negative 8 equals 4 minus 12. That's negative 8 equals negative 8. That checked out. So I would know that 2 comma 3 worked. And I could do the same thing for 5 comma 6. Right? You can always check solutions to one equation, systems of equations. Make sure that anything you're saying is a solution solves whatever equation or equations you're trying to use it for. All right, let's see number 4 here. So we have y equals 7 and y equals negative 5x squared plus 10x plus 127. All right, so that second equation looks like it's a little harder to work with. The first one, though, y equals 7, don't be confused because there's no x's or anything. It doesn't matter. If y is equal to 7, guess what we're going to do? Replace the y with a 7. Just like if it said 7x plus 2, we'd replace the y with 7x plus 2. So we're going to get 7 equals negative 5x squared plus 10x plus 127. And I could subtract 7 on both sides. So I'm going to get 0 equals negative 5x squared plus 10x plus 120. Now, if you're thinking, well, factoring doesn't seem to be good here. I've got a negative in front of my a value. Maybe I want to use the quadratic formula again. You can go right ahead. Okay, I'm not going to tell you not to use some other method. We can also divide everything here by negative 5. If I divide everything by negative 5, because 0 divided by negative 5 is still 0, and I'm going to get x squared minus 2x, and not plus, minus, so we have to change the sign there as well. Right? So we're going to have minus, okay, 5 goes into 120 24 times. All right? So make sure you're paying attention to the signs there, which I almost screwed up. Right? We have positive 120 divided by negative 5, so that's going to be a negative and 24. And now this is something that's more manageable to factor. So I'm going to have 0 equals x minus 6 and x plus 4. Negative 6 times 4 is negative 24, and I add those together, I get negative 2. So I'm going to have x minus 6 equals 0. X plus 4 equals 0. All factors set equal to 0, so I'm going to get x equals 6, x equals negative 4. And then I could plug that in. Now in this case, I have to plug that into the second equation, right? You think, right, I can't go and plug that in here. Right? Where did I plug it in for x? Well, actually, if I plug these in to this second equation, I should get 7. The y is always equal to 7, right? This would be a horizontal line. If I was going to graph this, right, if this was 7 right here, this would be y equals 7 would be a horizontal line going straight across like this. So any point on it is going to have a y value of 7, 6 comma 7, right? Negative 4 comma 7. So if I went out here, if I extended this and this was 6, this was a point 6 comma 7, and then I had, let's say negative 4 comma 7, I'd have those 2 points. That would be the 2 points there that I got that are solutions. My parabola, or I'd be something opening down with my negative there, so I'd have some parabola maybe going like this, right? Doesn't have to be exact, but we get an idea. We'd have a parabola and then this horizontal line going through it where the intercept are always going to have a y value of 7. So 6 comma 7 and negative 4 comma 7. So we can still solve that, recognize what that means, right? When the y is 7, that means the y value for any point that would be a solution for this would have to be on that horizontal line and have a y value of 7, right? So you could plug 6 back in and get 7. You could plug negative 4 back in, and there'd be a lot of work. Maybe you make a mistake with a sign somewhere, you get a wrong answer. Let's recognize y equals 7, horizontal line. So I've got my 2 solutions there. Once I found my x values, the y values, I didn't have to do any work for. All right, so solving systems of equations. When we've got quadratic equations, if we've got a y equal something, whatever that is, whether it be a number, another expression, plug that in for y, substitute it, then you're going to have an equation with just one variable, right? When we had this here, we have an equation with just one variable. We can always solve for that one variable. When it's a quadratic equation, you can use whatever method you want. I'm saying factoring typically is going to be something that can be useful for these. So you can factor or whatever method when you get your x values, plug those back in to get the y's that go with it, and you should have typically 2 ordered pairs. We could have them intersect in only one place. We could have them intersect no places, but most of the time you're going to get 2 points where the line and the parabola will cross each other. They're your solutions for the entire system.